Hey Geometry, I'm trying to keep my videos short. Maybe I shouldn't talk so much. They'd probably be shorter if I didn't talk so much. I've drawn a couple of triangles here. Let me actually get rid of this for you. I added a triangle here. Did you notice that this triangle is a little bit bigger than the other two? But do they look otherwise the same shape? Yeah, they do. In fact, if you pause it, you could even figure out that the slopes are the same by looking at this and see that these are the exact same angles. But this one has side lengths that are twice as long. So that's why just because, nice color, just because angles are the same doesn't mean that triangles are congruent. They might be completely different sizes, which means it's not enough to have all the angles the same. What you need to make sure you have is at least one side, because one side will lock the size in place. And remember, do I need all three angles of a triangle to prove the third angle? No, all I need is two. So basically what it seems to suggest is that if I have two angles and a side, that is enough. The two angles will guarantee the third, which guarantees the shape, and the one side, wherever it is enough to lock in the size. So let's get rid of that triangle right there. And if I have these two angles in place, and I also happen to have this side, that would be an angle, side, angle, and that's enough. Any two angles, any side is enough to lock in the shape and the size. But maybe I don't have that one. Maybe I have this side, in which case I have an angle, angle, side. So we have then two different types of things. We have angle, side, angle, or angle, angle, side. I view these as just about the exact same thing. Because again, if you have two angles, you have the third. So if you have these two angles, you have the third, which would give you an angle, side, angle idea. But they have, the people in the Big Gray Building decided that both of them are deserving of their own status, so we will give them that. So again, the goal here is going to be, can you show angles, two of them, along with a side? And if the side is between the two angles, you're going to have angle, side, angle. But if the side is on away from outside of the two angles, then you're going to have angle, angle, side. And that really is all there is to it. So if you have, oh, my Apple software is ready to install. Yay. Oh, go away, Apple. Back to this, back to this. So if we have angle, side, angle, and I'll let you look at the notes, that's probably make the video shorter. You can fill in these things on your notes, and I encourage you to do that from the answer key. But basically, if the angle, side, angle, congruency pairs are there, then we know the overall triangles are good. And likewise, if we scroll down to angle, angle, side, if these angles are congruent, these angles are congruent, and this side is congruent, then I know that the two triangles will be the same. Don't lose our focus. I've got the idea that if these three pieces are the same, that means all six of these match all six of these. And if all six of these match all six of these, then I have congruent triangles. So that is a pretty cool thing. Included was the angle, side, angle. This is non-included, which means it is the side opposite the angles. And that's the angle, angle, side. So there are some proofs we could go through. Let me see if I can find one that we don't know what the answer is. Nope, I don't have one of those. Let's do this one. I don't remember where we are in the notes, so let's see if we can figure out how this one works. And again, I'm going to talk to those triangles and fill them with all kinds of different congruency marks and see what I can see. Number 7, it says side LG is parallel to JM. I know what parallel, that's going to lead to some alternate interior stuff, right? So this side is parallel to this side, so let me get my highlighter so I can extend these sides out. And I've got all kinds of different alternate interior pairs I could make here, right? If I let this be a transversal, then I know that this angle is going to match this angle, right? So let me draw that in. I know that these two angles, let me one more time, this is going to match this. And now let me highlight the other transversal. Doesn't that mean this pair of alternate interior angles is also going to be congruent? So now I have this angle is the same as this angle. I'm not writing these down, I'm just talking to the text first, right? Now I've got one more thing. Oh, H is the midpoint of LM. H is the midpoint of LM. Doesn't that mean that this side and this side are the same? Yes, it does. So now I can put all these different pieces down. I know these are intimidating, right? Did you follow this? If you followed this right here with me, do you see that this is now an angle side that matches angle side? That is my goal for you. If you can create these, that's just gravy on the Thanksgiving stuffing, potatoes, and turkey. Okay, so Thanksgiving dinner without gravy is kind of dry, but anyway, this right here is extra gravy on the side. This right here is the meat and potatoes. But let's see if we can fill out some things. I might not do it exactly the same way the key has it, but I think that will be okay. I'm going to say that LG is parallel to JM. Why do I know that? Because it's given. Now I'm going to say that angle L is congruent to angle M. How do I know that? Alternate interior angles are congruent. Now I'm going to say that angle G is congruent to angle J. How do I know that? Alternate interior angles are congruent. Now I'm going to say that H is midpoint of LM, which is given. Do you notice how I didn't just list all the givens at once? I had a given to me, and I used that to prove some things. And now I know that LH is congruent to HM. Why is this congruent to this? That's just the definition of midpoint. What do midpoints do? Oh yeah, they separate things into two equal parts. And now, do I have an angle side? Yes, I do. So my proof statement then is LGH is congruent to triangle MJH. Sweet. How do I know that? How do I know that's true? Angle, side. Angle, side. All right, that's it. Give me an email and let me know if you have any questions, and I will see you next time.